Yes, and now I'm here to make it because I really but then I'm really interested when I started to use Leaflet inside Markdown was to prepare like kind of monitoring dashboards. It was so cool, but then at some point the information was yeah, maybe so heavy. Or what I wanted to ask you is if there is a, did you say at the beginning, that is kind of something important to upload a lot of high information, but also it is a way to automatize the process, maybe to open the information of servers and then to get it because this was daily. I don't have here the yeah, I think I don't have here my dashboard. I close it. Yeah, I wanted to show you, but it's not. So yes, I was wondering if it was if you have any recommendation or maybe a rule of thumb about the number of entities or the number of layers or something like that to display.
Well, with this approach that I'm showing here, you shouldn't have too many problems.
Yeah, because it's different, right?
Because you're not storing your data in the browser, you're just reading whatever you need to show at the time of rendering, right? So, I mean, there is a
because what I mean, the dashboards in R are so easy and so nice. And then it was something more or less like this. But then what I just linked everything, but these entities changes because their municipalities like advance every day in our but yes, at some point in Colombia, we have like 1,122 municipalities, and you have like a row for the advance. And at some point, I couldn't advance anymore.
Yeah, so maybe that should work, definitely.
But come on, this was like 4 years ago. Like right now, that's why.
Well, I mean, I guess 1,000 municipalities
should be
work in standard Leaflet.
Okay.
And usually they're not very complicated.
No, just right? Yeah, they were just like something. Yeah, and I wanted to ask you another thing, but I think it's.
Yeah, we can talk afterwards, right?
Okay, thank you.
No worries.
So in this case, the idea is to upload the information daily to such a server to create a service and then read it into the Markdown file.
Yeah, you could do that via cron job, for example, in the cron tab on Linux. You're using Linux, right?
Yeah, but that institution
not. Okay. But yeah, there is a scheduler as well in Microsoft, where you can do daily jobs, automated, run this script, and that script will just upload your data to the S3 bucket. That's easy. Okay, camera and microphone are working, right?
Yeah, it's all right.
Cool. All right, then I guess we continue with this, or shall we wait? Somebody's gonna get all the people in.
Second block, guys.
All right. So as I said, the second part is more or less about how to create those data that I've showed you in the first part. Again, we're not going to spend too much time on the raster because GDAL has been around for quite a long time, and that is the standard way of creating cloud-optimized TIFFs, in my understanding anyway. I know there's a few other options out there, but that's some of them are closed source and some of them are open source, but not as popular, and GDAL does the job. So we're just going to look quickly at how to do, or what two things you need to do to create a cloud-optimized GeoTIFF. And then the most part we'll spend on PM tiles and Tippecanoe on how to create these vector tiles. And have a bit more of a deeper look into the options that are there. As I said, there's many of those options, and I mean, if you want to try all of them, you need half a year, I guess, to try them all out. So I've just tried a few and was quite happy with the results. So I'll show you what I've done, and we're gonna do that live in this session, or I'm gonna do that live. Is there anybody with a Mac here? No, that's good. Ah, there is one. Okay, because I have no access to a Mac, so I have no idea how to install that stuff there. But given that it's a Unix-based system, it may work, but I'm not sure. All I'm saying is I can't help you. Sorry. For Windows, Flo and I, my colleague, we tried to replicate the instructions of how to install all the programs that we need, and we couldn't get Tippecanoe installed because it needs make, and make on Windows is definitely not easy to install and to get to work. But luckily, most of the newer systems of Windows actually have a baked-in Linux that you can fire up. And in Linux, everything just tends to work better. So especially when it comes to these compiling of things. As you see, I am on a Linux system, and that's exactly why I am on a Linux system, because building things from scratch and developing in the open source world tends to work a lot better on Linux than it does on Windows or Mac. So in any case, the software that we need for creating cloud optimized GeoTIFFs, as I said, is GDAL. I didn't put any instructions on how to install GDAL here, because I find that the SF package README has quite a good set of instructions for all the three systems on how to install it. And I'm assuming that most people here in the room actually have a working GDAL on their computer. I mean, checking how if your GDAL is working is very easy. You just type, why is this not working? Oh, it is working in the background, okay. You basically focus that a little bit bigger. GDAL info -- version, and if that gives you something back, then you can be more or less sure that your GDAL installation is working. So Tippecanoe has in their repo, and as I said, the Protomaps GitHub repo is now the one that you should use the Tippecanoe from, because the Mapbox original Tippecanoe is not maintained anymore. Has a set of installation instructions, but they are only for Linux. So there's no installation instructions for Windows. That's why I failed. And I think there's no installation for Mac either. So, sorry. But as long as you have make on the Mac, I guess it should work, because you're just cloning the repo using Git, and then you make install, and that's it pretty much. Yeah. Yes. Of course. Is that big enough? Yeah. Good. So as I said, we have Flo back there who can actually help with Linux for sure, and with Windows if you struggle to install any of these right now as well, because he knows how to fire up the subsystem, the Linux subsystem for Windows, which is a bit complicated that you run Linux on a Windows machine, but I guess maybe that's even the future, who knows. So in any case, there we go. So if you have that installed, typical --- version should give you a version information back. And if you see that, then your typical should work as well. And the last that we need is pmtiles, which is actually a Python module that has a command line interface. So you can easily install it with just pip install pmtiles. And then to test whether that works, you can just use pmtiles -convert space -h, and that should print the help for the pmtiles program. That pmtiles program consists of only 3 commands: pmtiles show, pmtiles convert, and then there's also a pmtiles serve that I think spins up a local host server, so you can serve local files via a local host onto your browser. But I have not tested that. Okay, so for my system, obviously I have set this up. And what I will do now, right now, is go through step by step through the creation of these files that I have done. And we're basically going to recreate all the files that we've seen in the visualization tutorial. Okay, so for cloud optimized raster data or cloud optimized GeoTIFFs, there's always 2 steps that you need to take. First, you need to generate the so-called pyramid overviews. There is a dedicated program for that is called GDAL-ADD-O for overview, I'm assuming. Or is it GDAL-ADDO? I don't know. In any case, that's what you need. You need to provide, or you can provide, a resampling method for the overviews, because you're basically creating lower and lower resolution files or images, and then GDAL needs to know how to aggregate pixel values, basically. The standard or the default is nearest, which I think is a very, very sensible default in this case for arbitrary reasons. Maybe it's just a copy-paste thing from the internet. I've chosen to take average, which I don't recommend unless you know what you're doing. The default is nearest for a reason, because that usually keeps the structure of the original image the best. Then you can provide bands that you want to create these overviews for. In our case, we have a GeoTIFF with 3 bands with color representation. So we're going to build overviews for all of these 3 bands. And then you just pass it that TIFF file that you want to create the overviews for. And these overviews will then be written into that GeoTIFF file. So there's no output file that you create, but you're updating the actual file that you have. Okay, so in our case, by the way, if you wonder why I have these shell commands that I have here online, again, written in a text editor, that's because Bash doesn't like these comments that I put here, and will not work if I just copy all of this, and it will trip my bash command. So that's why I have them copied over here without the comments. So if I do that, I first go into the directory where my files are stored. Here we have, that's actually the original that I downloaded. And then I've already created that GeoTIFF from this TIFF that I downloaded, where I basically warped it from a geographic projection to a web locator projection. So from lat long to web locator. So that's the input we're going to use. And then we are just going to do the GDAL add O. As I said, the resampling method is going to be average. Don't take that for granted. I think we should use nearest. In any case, it's average for this example. We're going to do this for all 3 bands, and this is the input file that we use. And then GDAL does its famous progress bar. And then you have the overviews baked into this file. And if you then go GDAL info of that file, you will see that you have these overviews created for these bands. All right, so that's basically tiled overviews that you create with lower and lower resolutions of your original image to be able to serve them quickly and visualize them quickly. So that's step number 1 that you need. And then you need to translate your raw GeoTIFF to a cloud optimized GeoTIFF. And that can be done with GDAL translate. Let's go here. GDAL translate, that's my input file, is the one we've just created the overviews for. The output file I'm going to name with a suffix of cog underscore defl for deflate, because I'm using the compression deflate. And my output format is going to be cog. So that way GDAL infers the driver to take, and that is in that case the cog driver. So doing that is also quite fast actually with GDAL. So if we do this, it takes a bit longer than generating those overviews, but still very, very bearable. Oh, sorry. All right, and if we now go and have a look at the GDAL info of this created cog file, we see that in the image meta structure, we have a layout equals cog flag in here now. And that basically means that we have successfully created a cloud optimized GeoTIFF, because in the earlier version of that file, there is no such entry in the image structure metadata. Okay, and I found out that the Sentinel-2 official cloud optimized GeoTIFF repository on Amazon S3 does actually not have this layout cog flag. So they are actually not proper cloud optimized GeoTIFFs, but just GeoTIFFs with overviews. And that makes all the difference, at least for the implementation of the R-Leaflet add cog function, because that means that you're downloading the whole file and not the tiles of the actual zoom level, right? And that renders it useless because these files are massive. So I'm not sure whether it's just bad luck on my side that I tried this for a handful of files and they were all missing that flag, or if all of them are missing and it's a oversight on their side to not create proper cogs. but rather only TIFF images with overviews. I'm not sure. I'm gonna dig a little deeper and then contact them and see what they say. But I'm guessing recreating the whole archive of Sentinel-2 into proper COGs is not really an option for them, because that will take years, I assume. I don't know. But anyway, so if we want to make sure that we have a proper COG layout, then that is the flag to look for in the image structure metadata of GDAL info when we print this. So we can also, and that is a nice thing of GDAL, GDAL can access everything that is accessible over the via the internet. Also, so you can also go GDAL info of that COG that is provided at the HTTPS URL in the tutorial from earlier, and that will also work. It'll take a bit longer because it's not a local file, but still it's fast enough and you get the same information. And here, the important flag. All right, and that is all you need to do. Then you can upload that TIFF file, and it just creates one TIFF, so everything is baked into the file itself. It's not like you have different files for the different overviews. It's one file with the different overviews baked into the file. And then you just take that file, upload it to your S3 bucket, and then you can use add COG with the URL wherever you put it, as long as you have access. So that's all you need to do to create a working cloud-optimized GeoTIFF. Or do you have any other recommendations, Leandro, given that you've worked with this quite a lot?
Yeah, I tested it. I remember I did some tests with the size of tile, and I noticed that for really large areas like 4.6 and Europe 30 meter, we use it like a bigger tile, so 1024 pixels. And I was also double checking here. I shared the Mattermost. We also use it like the deflate, but increasing the compression levels to 9. So it reduces more, but it like increase the time to decompress. But I think here the trade-off is
it's very easy because serving through the internet, the smaller it is, the faster it will be, definitely.
Yeah.
You gain much more with smaller sizes than having to recompress or decompress higher compression level, definitely. So that is then in GDAL Translate now. Where's that size that you can?
It's in the COG format.
Ah, it's in the COG format. Okay, okay.
It's a flag.
So it's a flag in the COG format. Okay, okay, cool. Thanks for that. All right. Any questions regarding the raster data creation? That's, I mean, there's no magic there. That's pretty easy, straightforward. No. All right. Then cloud optimized vector tiles. Now, I've downloaded, as I said, these building footprints for New Zealand, roughly 3.2 million polygons from the LINS data service. So Land Information New Zealand is a very, very good company. They provide actually that data in geopackage format, not shapefile, which is good. Step in the right direction in my mind. So downloaded those. Let's go here. And then use GDAL SRS info just to get the information on the projection of those downloaded geo package. And given that we're in New Zealand, obviously they're using the New Zealand map grid 2000, it's called. Each country has their own specialized projection, which works best for their territory. So it's not a wonder that you get something that is specifically projected towards New Zealand in this case. Now, when it comes to rendering vector data on a leaflet map, Leaflet always expects data in geographic coordinates, so unprojected EPSG code 4326. Always. There's no, that's the standard setup for a leaflet map. So we need to transform those. You can do that with OGR to OGR. And as I said, Typicano, which will be our next step, either needs an input format of GeoJSON or flat GeoBuff. Now, given that I've showed you that we can use the flat GeoBuff to render features at high zoom levels, it makes sense to not go via the GeoJSON route, but the flat GeoBuff route, because we can then take that file straight away, upload it to a S3 bucket and visualize it, right? So what I'm doing here is then basically go OGR to OGR. My target SRS or coordinate system is EPSG 4326. The output data file is nzbuildingoutlines.fgb, and the input data file is the geo package. I could provide the driver that I want to use, but GDAL is smart enough to infer the driver from the file extension, so you don't have to. And then that will take a bit of time because that geo package is not that small. It is 1.4 gigabytes because it holds a lot of data. There's a lot of attributes with this as well, which for the transformation of the coordinate reference system don't really matter, but it still need to be, they need to be copied over in the end, right? But yeah, it'll take a while. So I don't know, 1 or 2 minutes or something. So you get the impression that data preparation in this case is actually the hardest thing to do, or the thing that takes the longest. So, but in order to be able to visualize that much data on a map, these steps are necessary to do, right? And what I want to do here is give you the tools for that one possible way of creating and then visualizing these things for your own data, right? Because it doesn't help you if you can visualize anything that already exists, because usually you want to show what you've done to the rest of the world, or to your supervisors or your colleagues or whatever, your clients if you work in the industry. That's why I think this part of the tutorial is, even though it's not R, very important, so you can take these tools also and do it with your own data sets and play around to be able to then have these cloud optimized file structures. So as I said, this takes a while. Once that is done, though, we can actually go the typical route, and that's the next thing we do. Now, here we are already. The GitHub repository of proto maps. That's basically the GitHub repository that is relevant for this tutorial, because that has the PM tiles software. It has the protomaps.js, which you don't have to worry about because that's my job to provide that on how to render these things in the browser. And it also has a fork of the Typicano, and as I've said, it has now implemented that you can use flat GeoBuff as an input for the Typicano as well. So and here you will find all the documentation for Typicano as well. That README is extremely long because they describe all the possible things that you can set here in a lot of detail and have a lot of examples there. So there's also use cases for different scenarios. So it's well worth when you want to create such data, it's well worth reading through this, because you might come across something that is close to what you are doing, and then they have recommendations of what kind of flags and options to set to make that as visually pleasing as possible, really. All right, so if we go down to the actual options, there we go. Everything is described here, and it's nicely organized. So there's, as I say, a lot. So the O file is the name of the output file, write tiles to the specific directory, because you can do more tiles at a time, and then you just pass the directory. You can force things if they are already existing, and they will be overridden, and so forth and so forth. One thing that is really important is the layer name, because that is something that you will then need in the add pn functions in Leaflet, because without the layer name, we don't know what to visualize, because one PM tiles file can actually hold more than one layer. So that's maybe also a way to go for the different time slices, that you have different temporal layers in that one file. I don't know, I haven't played with this yet. So. As I say, there's a million options that you have here. I think the zoom options are something that you would need to know and need to use. The small z is the maximum zoom that you want to create tiles for. And as I said, the lower that maximum zoom is, the faster the tile generation will be. Then there's always the very prominent ZG option that you can set, which basically means guess what probably the best max zoom is for the data that you have. And then there's the big or capital Z, that is the minimum zoom. So you can say, I only want them to be visible between zoom level 6 and 12, for example. And then there's also this, what I showed you earlier already, extend zooms if still dropping. So that basically means it's trying to be smart and figuring out, am I still simplifying my tiles in some way? And if so, I'm just going to add one more level to the maximum zoom level, and then reiterate that again. And if I'm still doing some simplification, I'm going to go one zoom level further, and so forth. There's other ways that I'm going to show you as well, but that is one of the things that you will use more often if you do this, right? Tile resolution is something that is interesting. You can go full detail, low detail, or minimum detail. I'm not so sure what that does in the end, but that is something you could try. Something that is quite handy is if you find that your tiles are still too large, or that your process is taking too long, or that the actual file that you output is too big, you can actually in the typical call exclude attribute columns from your data. So if you have many attributes that you don't need for the visualization, you can just drop those in this call. You don't have to have another pre-processing step. You can do this all in one fell swoop here. There's also a capital X minus capital X. That means drop all of the attributes and only keep the geometries if you're only interested in the geometries. You can apparently modify feature attributes. I'm not gonna look into this, but there is something I wanted to show you. here. That's dropping a fraction of features to keep the tile size under the limits or close to the limits. As I said, you have many options here. You have drop densest as needed, which will basically try to figure out whether things are so dense or so tightly packed together that you at a certain zoom level don't see that anyway. And then it will basically try to keep, I guess, the biggest polygon, or if you say cluster densest as needed, it will basically render 1 point instead of 20 points or 2000 points. You can drop a set fraction, and you can drop smallest as needed. So that might be the option for the polygons to go, where you get rid of the very small polygons because you don't see those at low zoom levels anyway. And there's also an option where you can coalesce things. So that will then actually bind together the polygons, make one polygon out of many polygons, and simplify it somehow, I guess. So, and there is then also the cluster densest as needed. That is, I think they say mostly for points. It doesn't make sense to do this for anything else, I would say. Well, it might, I don't know. My understanding is it's mainly for points. So, so that should be done now. Okay, good. So what have I used for creating those footprints, building footprints in New Zealand? I tried with drop smallest as needed or drop densest as needed, but that didn't result in a visually pleasing experience, in a sense that at zoom levels where you already see or could see different or individual house footprints, you would only have every 5th building or something included. So at that stage, I said, okay, I'm not gonna drop anything here. And then I said, just because I wanted to try it and it still works quite fine, I don't want to do any tile compression. I don't want to do any feature limit, and I'm not going to set any tile size limit. Tile sizes are usually, I think, 500 kilobytes. That's the limit for them. And if there's too many things in a tile, then it will start dropping if you say drop as needed. So I just wanted to try whether that works, and it turns out it works, right? So no limits whatsoever on the tile sizes, but in the end, it doesn't surprise me that much because it's very small and simple polygons. Building footprints, usually some rectangles, maybe with up to 20 vertices, and that's maximum, I guess, most of the time. So there is not that much or that many complex geometries in there. So, and then I said it's important to have a layer name because otherwise we don't know what we want to visualize. And then that's basically what I've done. And here I just let the zoom, let typical guess the zoom. Still, turns out it guesses that for that file, apparently a zoom level of 18 is still something that is needed. So let's see how long that takes, because that is actually one of the bigger things that we need to do here. So it will print certain information while it's doing this. So first of all, it reads all the features and does that quite quickly, actually. Then it reorders them somehow to have a better structure, I guess, optimized for what is about to come. And then you will get some sort of information about the zoom levels that it's guessing, I think. Yeah, choosing a maximum zoom of 11 for features that are about 143 feet apart, and choosing a max zoom of 14 for things that are about 8 meters apart or within the features. And then it basically just goes through all the zoom levels and the X and Y tiles that it creates, and will give you a counter of how much is finished. And then you just have to wait and stare at the numbers, basically. So, and that will take a while. So this is, as a ballpark, 3.3 million polygons. So a medium-sized data set, I would say. And it will take a few minutes, for sure. Any questions so far? Is anybody actually joining me in doing this or not?
No.
No. Okay.
Please installing Hello. Fail installing Hello.
Okay. Is that Windows?
No.
Ubuntu?
What's the error message?
Yeah. What's the error?
Copy paste and not.
Yeah, or you could ask Flo. Flo could try to help. Thanks, Flo. So we're already here at zoom level 6 and roughly 50%, so it's not too bad, right? For Germany, it takes about 3 times, or yeah, 2 to 3 times the amount of time, but that is only points.
Why you are not using the compression? There is some.
I would, well, in this case, because I tried, I just wanted to see if I don't restrict anything, what it comes up with, and whether it's still usable as data to be rendered. And it turns out, yes, it works. And then I just moved on, basically. So, yeah, that was just curiosity.
Yeah, I'm asking because maybe depending on the compression algorithm, I don't know if this is like really compressed. It relates to the compression, right? Like the geometry.
I would think so, yeah.
So depending on the algorithm might not be supported in the browser, right?
No. I mean, if you don't specify no tile compression, then it will compress it by default.
Okay.
I think using something like gzip or something. Let's see. So don't compress the PBF vector tiles if you are normal gzip compressed tiles. So using gzip. So I'm assuming that when you do tile compression already and then provide the PM tiles command that comes afterwards with the gzip flag, then it can't compress much more, right? But in this case, it can actually reduce the file size quite drastically because the tiles are not compressed. So then PM tiles is going to do that for us. All right, there we go, done. And then the last bit that we need, which is really quite simple actually, is just the PM tiles convert. And I'm giving it the gzip flag. I could have done that here, I just found out, so I'm guessing in any case, it'll still gzip everything around it, so you still gain a little bit of compression here or file size. And then you just provided the input file, which is the MB tiles, and the output file, which is the PM tiles. And I have to put the override flag because it already exists in my folder. And then it will just go ahead, do the compression, and then have the PM tiles created. And that is then basically the file that you upload to your bucket and visualize. So that is quite easy. And I mean, if you want to benchmark this, I guess you're going to write some sort of a loop wrapper around it, whatever, to just say, try this, try this, try that, load it up automatically to the S3 bucket, and when it's there, just have a play around and see what it looks like, right? So, but yeah, that's pretty much all there is. And once this is done, we can use PM tiles show to give us a little bit of information about these things. I just got an email via Twitter from the Protomaps guy yesterday, because I asked him why it is not possible to use PM tiles show on a remote URL, because that doesn't work. You have to have the file locally to get the information about the file, which kind of defeats the purpose of creating a cloud optimized software stack, right? So he said it's not implemented yet. It's, I don't know, but it should be there, and it's going to be in the next version. So then we should be able to use PM tiles show or get information about the tiles straight from the bucket, which makes a lot of sense in my mind. So yeah, so that also takes quite a while, because zipping apparently takes a bit of time. But that is pretty much all there is. And then, I mean, the output of the PM tiles show for this PM tiles file gives you quite a bit of information. It gives you the spec version. It gives you the name of the input files. It gives you the guessed zoom levels. It has the center and the bounding box. And then it also, and that is quite nice, gives you the creation options from the typical no-code. So that is recorded there as well. And it gives you a bit of a preview of what's in the data. So what's the build, the fields that are in the thing, what's the layer, which name, how many are there, and all that kind of stuff. So, and then it's gzip and how many tiles directories you have. So you're creating 6,627 tiles basically for this data set, which for such a small area is still quite a lot, I would think, but that is actually what makes it render so nicely. So are we done here? Yes, we're done. In this case, we have even close to 60,000 tiles. So this is only the root directory tiles. Okay. In any case, whatever that means. And yes, and when we visualize it, we've seen that that actually works quite well and gives us all the data we need. So yeah, that is, I think, pretty much everything that I've prepared. So there is a lot of room for questions or trials. I could come around and help people try to replicate or work with their own data as well. I mean, there's not much more to say at this stage because nothing more exists, right? This is work in progress of a hot topic that is quite young. And I'm curious to see what the OpenGeoHub Foundation is going to do with this. Because it seems like you're going to try this, right?
Yeah, sure.
Good.
Give us how much longer? What's the list? 1 month?
Yeah.
We'll try to put all our data. And you can, when you render these points and stuff, I mean, you make this leaflet and you can embed it in a book base. You can just go every data set and you just put them and you can visualize the data.
Yeah, I would think so. I mean,
No, it's amazing.
And it works in Markdown, obviously, or Quarto, because this is a Quarto document. So, and the nice thing is you're keeping everything that is related to your web page quite small, because you only have the code embedded in the web page and not the data. And that's usually what inflates the web pages and makes them really unusable. In standard Leaflet, all the data is copied as JSON into the HTML file. And if there's too much, it'll just stop working, right? So, I mean, one thing that I could show is, if people are interested, there's like an intermediate thing that we have in R that is called LeafGL, which I'm also the maintainer of, which is for like medium-sized data that uses WebGL rendering. I mean, we have a lot of time left, so if there's interest, I could just quickly show a few examples of that and what that kind of looks like, and how to use that. Sure.
Did you try to benchmark it somehow? So in terms of use 1 hour of computing time to save 50 gigabytes of space on your cloud?
No, I was glad that I finished what I have on time yesterday. So no benchmarking so far. Yeah, I mean, in the end, that is something that you just need to accept, that big data needs time to be processed, to be optimized for whatever you want to do, right? I mean, when you do machine learning, most of the time you spend is on data pre-processing, and it's no different here. But the result is then actually something useful.
So I think the user online document maybe leaves your page, it takes too long to load. If you scroll down another layer, zoom level, and it takes forever, then it just closes and this application you can keep on spot, so to say. So I guess it's really worth it to have a better performance when presented to someone to have a better experience.
Yeah, definitely. I mean, that's why I decided in MapView to switch actually to FGB rendering rather than normal Leaflet rendering, because with normal Leaflet, it means all of the data that we want to visualize, you create a big GeoJSON file, and then you pass that on to the browser, and the browser then reads, or the JavaScript that runs in the browser reads that whole thing in, and only when it has it in memory is it going to visualize the map. So if the data is not that big, but still too big to take a fraction of a second, maybe let's say it takes 5 seconds, people get really, they're not very patient, right? And with the flat GeoBuff rendering, first of all, it's a lot quicker to create the flat GeoBuff file rather than the GeoJSON file. And then serving that can be done with streaming, and that is the default that is implemented in MapView now, which means that you can have the map instantly, and then all the data is streamed onto the map. I mean, we can try this with, let's try this. MapView, let's see, at my FGB file is home 10 downloads. Let's take the rivers, because that I know is bearable. So if we do, and then we go MapView, and then that should actually work somehow, I hope. Okay, there you see it already takes a while. It doesn't work at all. S2 is always a bit tricky. Well, it's doing something. Or maybe I've just crashed it. Yeah, seems like it. Here we go. Okay. Whatever it does that, I don't know. Maybe that was too much data. No, here we go. I see now. Okay, that was not using the flat cube of rendering. Let's just go back here and do it differently. Oh, come on. Let's do it that way. So again. Use actually SF to read that in, because then I'm fairly sure it's going to use that flat cube of rendering. So read SF, just to read better. And then go and maybe go pop up this false. What? Let's see how long that will take. Must admit I haven't used. Oh, there we go. So there you see that you get the data streamed onto the map, and that makes for a more pleasant experience, right? Because you actually get the feeling that you know what you're waiting for, right? So, and I mean, you can zoom in and out and everything, so that actually works. But it in this case, because I didn't specify the min or max zoom, it'll just render everything still, right? And you can visualize a Hilbert tree basically that way, because that's what it's traversing here, right? So. But having said that, there is a map view option platform. Map view options, it's called, I think. Platform is LeafGL, which for this type of size of data should work quite well as well. So we have line string that should work. And then go map view TST, and that is then using WebGL now. That does not have the streaming. The combination of those two would be ideal in my mind. But the guy that is implementing Leaflet GLify doesn't have the time to actually provide a reader for flat GeoBuff serialized stuff. So that's why here it takes a bit longer for the map to be rendered, because everything needs to be rendered at once. But then this is basically WebGL and really performant now. So, and I think you do also get all of the information there as well. Yeah. So, I mean, that is a library called LeafGL, and I think if I go add GL points. There should be an example of, yeah. So here we have this example. It can be a little bit more advantageous here and go 1 million points. So if I use this, I'm just creating a data frame of 1 million points with just random lat long coordinates. Convert that to an SF. Use some colors, and then I can just add GL points to my leaflet map, and that will then again use the WebGL rendering in order to visualize this. So it's like an intermediate step, but as you see, it will take a lot longer to generate the map, because here we still have to create all the data, convert it into JSON, pass it to the browser needs to read in all the data and can then only visualize it. So the GL part really only helps you in the performance of the map here, right? But that is actually then really performant, and you really get a really nice feeling. So, and again, you get all the attributes that are there. So depending on the size of your data, but for that, you don't need any pre-processing, right? You just read it into memory and then create the map. So that's why I say it would be much, much nicer to have that rendering engine being able to use HTTP range requests and then successively fill the canvas or the WebGL instance. But I'm honestly not even sure whether that's technically possible, because as far as I understand GPUs, everything needs to happen at once. And you can't have GPUs be switched on and off. You just have to, you can invoke them once, then they do their thing and that's it. But that's my limited understanding of the whole thing. One caveat that this WebGL rendering has, and that has nothing to do with R or the implementation of Leaflet or anything, any browser only allows a certain number of WebGL instances to be instantiated or initiated or be created at a time, and that's usually around about somewhere between 8 and 16 WebGL contexts, and that matters when, for example, you use that as your rendering engine in a Shiny application where the user can redraw the map all the time, because it does not kill the WebGL instance when you redraw a map. It'll just reinitiate another WebGL instance, and then you lose the last one that was created before. So everything that you will want to show in a successive manner or whatever, you will only have a limited amount of things that you can show. There's a few issues on LeafGL that basically deal with this kind of stuff, but there is no real solution for it. So, but if it's just for one map, one instance with semi-large data sets, then LeafGL is definitely worth exploring, for sure. So, any questions there? All right, then I'm really out of content now.
Okay, well, we can start. We have also dinner tonight, so we have more time to prepare. Thank you so much, Tim.
You're welcome, and sorry for not enough content, but
No. This thing to prepare is very useful, and we will use. So, but there's still a lot of development, and I think was critical is the time. I think, and then both in the process and the points. I'll deal with that. And then we, you want to minimize number of copies you make of the data, right? That's also, I see. What copies. It's okay when you do some. 100 gigabyte file. Yeah, but it's amazing, yeah. So thank you so much one more time. And, if you have questions, you can still ask on the MetaMost. Just post the MetaMost, and otherwise GitHub.
Yeah, find me. Yeah, that's
What's the
definitely.
next conference we're going?
I don't know actually.
No?
No.
Plans for next year?
Well, if there's a user conference, I'm definitely going to go to that one.
Okay.
But as of now, there's none. So I don't know. Maybe I go to the our studio conference or something completely different. I don't know yet. We'll see.
Okay. Well, let's see what next year will be. Okay, let's go.
Cool.
Thank you so much.
Thanks.